Amy's from Kashmir, Mark's from Otago Boys, and they're here to talk about scholarship stats, and I'll hand over now. Welcome. Thanks so much.
Kia ora, everybody. It's Mark here from the deep and frosty south, but a sunny day down here in Mosgiel, just over the hill from Dunedin. And Amy, you're on mute. Better introduce yourself.
Yeah, so I'm Amy Hooper. I was on mute because I've got a frog in my throat. I was trying to clear. I'm from Kashmir High, and it's beautiful and sunny here today as well.
Okay, so we've prepped something. I was just saying to Anne before we got going, and everybody was lit into the session, how I only got to learn about these AMA mornings last year and attended most of them last year, and just think they're fabulous. So Anne, top raps to you and your team for putting these on. I know they're slowly spreading south. I tried to encourage a few from town to come in today, so I don't know how many have gone to other sessions, but it is the news is slowly creeping south. And part of the structure today, guys, was inspired by a session I attended at an AMA day last August on a Saturday in August. It was the Saturday after we went into level 4 lockdown, so there was certainly nothing else to do on a Saturday morning other than learn some good maths and stats. And it was, I'm terribly forgetful, and I apologize hugely about, I think it was a teacher named Dave from Rangitoto who led the scholarship calc session. And the relief and inspiration I got from that session and the great work that Dave and others were doing has sort of helped me and Amy to sort of structure how we're going to share what we do in our schools. And there's some similarity between what we do and there's some differences. Amy and I have been colleagues and mates for 4 or 5 years now, and we share ideas. When I travel up the coast to Christchurch, we often talk over a coffee about what we're doing, and so that'll come through in our session here. But there are some differences in how we do it in our schools, and it'll be very cool to see how 2 schools contextualize it for their local area. So kia ora from the deep south, and the reason I'm putting those 5 digits together, and we can easily work out the probability if they are selected at random, 93201, is that's the standard number for scholarship stats. So if you ever want some past papers resources on the authority's website, you can just type that into Google and it'll take you there pretty quickly. So let's get this moving on. So it's Amy Hooper and myself. You know where we're from in our schools now. Look, and our plan today, guys, is to we want to share how it works in our respective schools, and sometimes not. And there'll be some sort of fails and some amendments that I've known we've made in my own school to try and make it work a wee bit better. So that'll be the first thing we share with you. And secondly, I want to introduce the fantastically successful, something that I thought would never work with boys especially. And there is a bit of a boys focus when I share our ideas, because that's the focus and context that I'm working in. And that's the successful Righty Righty. And then Amy's going to lead a little session on exploring data, which Amy and I, when we've met over the last few years, feel is just in line with what Anne said through her introduction. Like, what is that spark? What is that extra? What is the broader, more critical, evaluative thinking we want our scholarship stat students to be able to do? So Amy will lead that in the third part. It's not just about drilling, kill and passing the exam. And then I'll share some ideas about what we call tricky probabilities, TPs as the boys call them down south here, and about how we model and do those, and the importance of still being good at that calculative side within the statistics scholarship delivery. And then Amy and I are going to share some activities. I've got some photos to share with you, and if timing works out well through to 1 o'clock, the most successful that I've been involved in, the best activity I've shared with boys and other teachers is called the triangle taste test. And so the best thing selfishly about preparing over the last week for today was just reflecting and re-engaging with some activities we've done at Otago Boys over the last 6, 7, 8 years and much more recently. So I feel quite privileged to share some of the successes and fun we've had in those. So there might be some time for Q&A, but hopefully both of us have waffled enough so we won't embarrass ourselves any further. Okay, but we want to hear from you guys. We absolutely want to hear what's working in your schools. Maybe we can do a follow-up session either electronically or by Zoom. So look, I just wanted to start with this slide here about what I call the straight up facts about scholarship. I never used to do this in the early days of teaching scholarship, but I've worked out, I think, that students like to know this and they need to know this. And I don't know if you know, how many of us in the room know about this, or how many of us share it with our students and our other teachers. But we know that scholarship is different in the fact that it's a competitive ranked exam. So naturally, one of the questions which will drop out from our students and our colleagues is, well, how does that work? And this is literally amended a little bit more for students, but this is how I introduced how scholarship works for boys. So scholarship, and all of this information on this slide is publicly findable, but it's quite difficult to find. So I've just learned over the years how to find this pretty quickly and share it with us now. So it's scholarships based. Apologies if you know this, and please put in the chat room, hurry up, Hooper, we know this, move on. But it's called the 3% and the half plus one and the 3/4 plus one rules. Those are the fundamental 3 base rules on how kids get scholarship and how we can, particularly in term 4, train them to get to that point. So the 3% is based on the, in statistics case, it's based on 10,000-ish, okay? And that's the national cohort for level 3 statistics. And a few years ago, I remember emailing one of the people in charge of maths and stats at NZQA, how do you work out the national cohort for level 3 statistics? And you are counted as doing level 3 statistics if you do enough assessments that get you university entrance in that subject. So in level 3 statistics, we know there are 7 assessments of learning, each at 4 credits. Students need to be doing 4 of those assessments at least, and they would count as being in that 10,000. That's roughly each year the number of, typically year 13s, obviously, that's the number of students who do level 3 stats. The 3% is based on that 10,000, and that's the number of scholarships every subject gets in statistics. And these rules are the same for all subjects at scholarship. So 3% of 10,000, roughly 300 scholarships are awarded by the authority. 10% of that 3% is at outstanding. So that would be 30 out of that 300. And that, as I said, that's the same for all subjects. Okay, it does vary up a little bit higher and lower each year, but that's the rule NZQA work on. Now, interestingly, again, this is findable from NZQA annual reports and other things you can dig into their website, but 1,200 people enter in statistics scholarship each year. And the dropout rate is about 300. So 900 actually sit the final examination. And because of that 3% of 10,000, so the fixed value of 300 scholarships, the 300 who drop out are actually doing the 900 who actually end up doing the exam a wee bit of a favor. So in finality, that 300-ish out of 900-ish actually get a scholarship. It's about a 1 in 3 probability, and I'm actually straight up with our boys and saying, if it was based on random distribution, if it was randomly distributed, you're actually more likely not to get a scholarship than get it. But then I say to the boys, it's not at random, is it? That's why we're here in this room doing these tutorials. That's why we commit to these times from mid to late February. So that's what our job is, to actually make it better than 1 in 3. But those previous bullet points share how scholarship works in New Zealand, and specifically some of the figures around statistics scholarship. It is, as we know, a scaled exam. So the 3% was explained there. The half plus one and the 3/4 plus one, it's a minimum of half the marks available plus 1 to get scholarship across all subjects. Up to last year, that meant getting at least 21 in scholarship stats. This year, it was in a circular 2 or 3 months ago. The exam is moving to 32 marks, I think, based on 4 questions. I'm inferring that it's going to be 8 marks each, the same as in previous years with the science and calc exams. They seem to be sort of 8 marks per question. So I'm basing it on the fact that it will be a half plus 1 out of 32 marks, so 17 to get a scholarship, and a minimum of 25 out of 32 for outstanding, 3/4 plus 1. It is scaled. It is scaled to make sure 300 are awarded the scholarship. So it's back to, I just started my time in New Zealand just after NCA started, so I didn't get to experience how School C worked, but it has a bit of School C-ness scaling very much still in there. But 3% out of 10,000, a half plus 1 and 3/4 plus 1 are the golden rules. And I share that with the students right at the start, just to be upfront. And I think I've learned the boys in our context do appreciate that. A little bit less than me in a moment. I was just going to share how we do it, and I've called this the essence of infinite goodwill. When I turned up to Dave's scholarship calc session last year, I thought that Rangitoto and Mount Albert Grammar and all those big schools, especially in Auckland, had billions of timetable lines and classes of 6 scholarship students. And Dave made it pretty clear that he gives up a truckload of his time, like practically every other teacher who does scholarship sessions in the country that I've connected with gives up their own time and does it at some weird hours, as you're about to see. We tried at Otago Boys for a couple of years the preschool session. The boys were pretty hopeless. They're definitely not had Southern men in that regard. They were bloody hopeless at getting to school on time. But I know that model works well elsewhere. I know that Wellington College have dozens of boys turning up at 7:15 for their morning sessions. So I've heard that it does work. So over the last few years, we've moved to generally 2 sessions per week on a Tuesday and Thursday at those times. And the reason 6:30 to 8 works for our context is boys can go to sports practice, they can go home and have a bit of relax, they come back in and they actually finish at a time where they can go back and have a bit of family time, do a bit of homework, just relax before going to bed and getting ready for school. This year, because of the second bullet point coming now, we've actually added a 3rd session, and we do 3 sessions across Wednesday and Thursday this year. The main session with about 10 or 11 boys is straight after school on a Thursday, and we have about half a dozen boys each at the Wednesday and Thursday at that 6:30 to 8 p.m. slot. And the reason we've added an extra session this year at Otago Boys is because we do encourage with some good mentoring and negotiating with parents and a really upfront, honest conversation, we do encourage our year 12s to give it a go. And in fact, I was saying to Amy when we finished prepping last night, I think of our top 8 students doing scholarship stats this year, 3 are in year 12s. We'll have about 20 to 24 that enter the exam at the end of the year. I think in the top 7 or 8, three of them are our year 12s. They're pretty smart cookies. But time to share how Amy does it at her school.
All right, so Kashmir, and Mark's going to put up the words right. We meet once per week. We've been, for the last couple of years, we've been meeting 7:30 to 8:45 a.m. and that's worked all right. It does mean that you weed out the kids who perhaps aren't so keen pretty early on. But we still ended up with a core of around about 12 students each year. We tended to be very female heavy. I'm just going to point that one out in those ones, not so many of those boys along to the early mornings. This year we've switched back to afternoons, so we have a study period for our year 13s on a Thursday, which we take advantage of, and they come along from about 2 to 3:30, 3:45-ish, and that's every Thursday. So unfortunately that does clash with another scholarship tutorial, so it's likely we'll put on maybe some morning sessions or maybe holiday sessions for our students as well. But otherwise there's lots that we post on Google Classroom, so if they miss it and they're prioritizing for one week the other scholarship session, they can still catch up. We don't encourage our year 12s. We don't tend to accelerate our year 12s through the statistics program at all. We feel like there's a lot of context and a lot of just life knowledge that they actually need to really be successful. So our year 12s are encouraged instead to come the next year, come in year 13. So they do get the opportunity, they just have to wait a year. But it's whatever works for your school. Cool.
Amy's point there is just reminded with just the difference in allowing our year 12s to do. One of our year 12s that's doing it is an incredibly talented athlete, and I'm looking to get a contract with the Otago Volts cricket team, and no doubt they'll put some pressure positively on him next year to possibly, for the equivalent of a timetable line, go down to the cricket nets and do some bowling with them. But doing scholarship and level 3 stats a year really will allow him to do that. So that's what it meant by the long-term lens there. Look, the headline there, the very essence of infinite goodwill, I do find, and I'm pretty open with our boss down here, that I do point the finger and say this is something you expect to happen and for teachers to make happen, but it's nowhere near as well resourced as the sports teams at our particular school. And I get the eyeball roll and just get on with it, hoop a look, and we do just get on with it, and we have tremendous fun. But there is a tiny part of me that wished around the country and in my own school that it was a little bit better resourced and more encouraged from within the school setting. just moving on to what we call the structure and philosophy, and this is actually a phrase taken from Dave's session at the Scholarship Calc session from Rangitoto last year. Dave made a really good point that there is no such thing as a scholarship curriculum. We know that, as we say to our students, you've got to know the level 8 curriculum really well, all the topics and all those 7 assessments of learning in level 3 stats case. We know the questions at scholarship and the type of thinking bind together 2 or 3 ideas at least. It very much de-silos what I think many of us would criticize NCA for, in the fact that it is a little bit too siloed in its own holes. Scholarship definitely breaks that down, and one of the skills is to know that curriculum so well that we can tie those ideas in. So we very much start through the probably first third quarter of the year in scholarship stats at filling in the holes that are not done at level 3. So in our case this year, that would be bivariate and experiments. We're a bit of an old-fashioned traditional boys' school. We teach the content at level 3 for all 3 examinations, and most boys end up giving a go at 2 of those 3 examinations. But yeah, our school does 3 externals and 2 internals in the level 3 course, which leaves we fill in the holes for bivariate and experiments. And then through the course of the year, as the boys have all that content coverage at level 3, level 8 on the curriculum, we start to add value by exposing them more and more to ideas which tie multiple linked areas together. So that's how we broadly structure our curriculum. But there, as Dave said last year, there is no such thing as a scholarship curriculum. It is based on knowing the level 8 curriculum really well.
So Kashmir's kind of similar. We do also fill in those gaps because we won't cover everything at level 3. We try to cover a lot of them during the first half of the year, but we also like to align what we're doing a little bit with their what they're currently doing in their normal statistics classes as well. Especially when it comes to things like they're at the end of their unit that's going to be assessed and it's an internal assessment. It's quite nice just to extend that thinking a little bit further there while it's fresh. Try and get the energy up a little bit before they go and write a huge report often. So that's how we approach it. And then just revisiting things throughout the year as they come up as well. Yeah, I think we're at the righty righty.
Yeah. So I can definitely affirm from my own school experience, and I'd be interested when I connect with, I see some friends and colleagues in the room now, but I'm convinced that after 3 years, and I'm a big proponent of boys education. I think for the boys that choose and families choose, single-sex boys education does work, but our boys are quite often sick and tired of NCA at the end of 3 years, because across 6 subjects per year, 3 or 4 internals per year, it's always a written report in terms of doing that assessment of learning. And it's a challenge in our school to try and think of different modes and more innovative ways of doing those assessments of learning, not just written reports. But by the end of level 3, 3 years of it, boys have done dozens of written reports, and they are over that aspect of how learning is assessed. We always still, and this is a complete contradiction to that first statement, but we do know that a scholarship is a time-bound 3-hour exam. It's lots of analysis and interpretation. And so practicing that writing and getting the boys' writing speed up with a statistical frame on is really important. So we always finish our sessions at Otago Boys. Every single session finishes with a Righty Righty. It's a name given to the activity by the boys in the 2015-2016 year groups. They called it a Righty Righty, and it's just something that's carried over. And I understand that Amy has now nicked it for Kashmir. Her students use it as well. So we always finish with a Righty Righty. They are begged, borrowed, stolen, made better, occasionally our own, copied, questions from previous exams that are worth an equivalent of 3 or 4 marks this time of year. So typically this time of year, we make the boys, and the boys actually do it fine, of course. The boys are there for 10 to 20 minutes at the end, and they answer a question. In the italics text and the bold, we do mark them. Oh, and something I forgot to say 2 slides back was, for the last 2 or 3 years, we've done scholarship session. We co-teach our scholarship stats session, and that's been an absolute joy to do that. I would really, if you can bring on a younger colleague, someone else who's keen to learn, it is a commitment. It is another sports team that we do with the way it's modeled. But I co-teach scholarship stats with a good mate Paul, and it's just an absolute joy. We clash on how we positively clash on how we approach probability questions, how we see it from different perspectives. It's a real big value to the boys. We feel that they can see two teachers look at things differently. In light of the Righty Righty, we mark them religiously and we feedback every week, and we've learned to mark them in line with, we've looked at enough scripts that boys have brought back over the last 2 years. If you see any of your students' scripts over the last 2 years, you should have noticed down the right-hand side margin, it says 1S or 1O. And it's pretty clear that's lining up with where a student has picked up a scholarship mark, six scholarship marks per question. And then there are 2 outstanding marks per question with a 1O if they've picked that up. I never thought the boys would like this when we started it 7 years ago or so. I know I wouldn't like it, and some of me doesn't still like it, but the boys each year, we always get a little feedback survey, and the boys overwhelmingly, particularly those who you connect with who got scholarship and you meet up with them, bump into them in town when they're at university the next year, they said quite often, this is anecdotally of course, but that was the thing that helped them get it in terms of writing speed, exposure to questions. Amy, when she talks about her exploring data in a moment, we'll talk about some of the mistakes that students make early in scholarship stats, which the Righty Righties help get rid of early in the piece. So they are well regarded by boys. If not loved, they are seen as really, really useful. And I think most of the boys do actually like them, but they do really appreciate the feedback. And that's a significant extra workload each week to mark up to 15 or 20 scholarship questions within the space of a week with everything else that we do in school. But it's something that Paul and I might make ourselves do. I'll just share a couple of brief examples of what we've done at Otago Boys. One of the sessions, one of the Righty Righties we've done, and this is one of our own that we made up. So as we know, a great thing on the level 8 curriculum for scholarship stats is to get kids to respond to claims using statistical thinking. So there you go, boys. Hollywood is a sexist cesspool of male pale staleness. And we get them to link onto that website at the bottom. And they have to write worth 8 marks, a response to that claim. Making up a schedule for 8 marks based on your own question is pretty interesting. But if you link on that, Pudding Cool's a great website with some fantastic statistical activities and in this case, articles. But that article linked to this website called Film Dialogue. It has some fantastic infographics which break down. You can see this infographic here about the Disney films and the breakdown of male and female dialogue. And it's got a temporal element there about how Hollywood has changed to sort of increasing more female actors and female dialogue in their movies. And so the boys are looking at these infographics and the text, and they're constructing. That one was done quite late in the year, this particular Righty Righty, but that was a full 8 marks, and the boys are looking at the website, silently writing, thinking, interpreting for 25-30 minutes. In our folder of Righty Righties, this is these bottom one halves here that I'm getting a little bit more organized this year. Righty Righty 1, Righty Righty 2, Righty Righty 3. Those are ones that stripped off straight from our more recent exams in scholarship stats. So that's a straight copied from previous actual exams from the authority. And those are little 2 and 3 marker ones. You can see the EDA title there. That's the exploratory data analysis. Amy will talk very brilliantly about that in just a moment, about upskilling our students on that. So those have worked well, just to get the 10, 11, 12 minutes of silent Righty Righty at the end. The great thing about doing Righty Righty is that it allows us to expose our kids to quite heavy duty scientific papers. This was one from the New England Journal of Medicine, one of the foremost journals of medicine in the world. And it talks about, I know people in the room would have seen this scatter graph before about chocolate consumption and number of Nobel laureates. And of course, if you eat more chocolate, that country is going to get more Nobel Prizes awards. So getting the boys to read through that and respond to a claim that eating more chocolate gets a country more Nobel Prizes was a great Righty Righty to do at the end there. Just to share how we feed back, on this screen here, you can see how this is how, for 4 boys a couple of years ago, how we were feeding back to them. These happen to be 4 particularly competitive boys, and they were very keen to know, sir, can you use the feedback you're giving us to try and give us an early prediction of what we will get in the exam? And you can see in that grey highlighted column, we're trying to give them a prediction of their result. And our final prediction and all this feedback. And I am showing you this, that if you decide to do something like a Righty Righty, it's worth committing to and doing well, that we religiously feedback and record the marks and give them a grade. And that final prediction there in that second grey column ended up, I was just sharing with Amy this morning or last night, that final prediction there ended up only being 1 or 2 off. So those were 4 competitive boys who actually ended up doing really well and got 4 scholarships. So again, their feedback was that the Righty Righties really helped. I'm happy to, at the end, if there's a demand, I can spend an afternoon, an hour or 2 pulling together what we've done at Otago Boys and sharing the Righty Righties if there's demand for that.
I want them. we use Righty Righties as well. Most of ours are based on the scholarship questions from past papers. But you definitely can see as you're marking them, we do mark them every week as well. As you're marking them, you can see just that progression through. They start off and they haven't got a clue and they're missing big things like putting in numbers. And as they get along, that ability to know, oh, I'm answering this question, so I need to put a number in here, or I need to use this type of language. It doesn't take them long to pick it up, but it's really useful. So data exploration, if you go and have a look at your students' past papers, or if you have a look at the markers reports, it's part of the scholarship paper that our students don't tend to do really well in, especially our students who perhaps are really well versed in some of the more complex parts of the paper. So they're doing those really difficult TPs. I thought that was toilet paper, Mark. They're doing the really difficult, tricky probabilities. But when it comes to the EDA, the exploratory data analysis, they let themselves down. So at Cashmere, we tend to start every single session with a really quick do now that often turns into not so quick because they love to discuss, don't they? And we do things like this. We'll look at, for example, different data displays, and we like to get them to be quite critical of those data displays. So Best in Show is one of my favorites because I have dogs, and I use it probably to find out more about the students' dogs than anything. But no, what they come up with is fantastic. Just the deeper questioning, like how did they get the data? Where did it come from? What else can I find? Using interactive displays is really useful. The next one, perhaps a little bit more complex for them to figure out. Again, it's those questions like, what do you see? What do you notice? What questions do you have? No inferences, but just stating the basics really, and then exploring the data and seeing what else they can find out from it, or what else they notice about it, or perhaps what bigger questions they have from it as well. So those are really useful. They're all from Information is Beautiful, and they're a nice, easy way just to start the discussion early on. Scholarship works best, in my experience, when our kids are happy to talk about things, and showing them something that's perhaps a little bit out of the norm. It's not the type of data visualization they're used to, and getting them to talk about it is a great way to break the ice and to start those conversations that then flow into the rest of the session. So some other things that we do, if we go to the next slide. When you're introducing, we don't actually teach time series to our statistics classes, not our top statistics classes. So the students in scholarship don't tend to have seen it before, not for a really long time, and they don't really know where to start. Sometimes going at it backwards has been a really good skill to get them thinking more about things and understanding how they might explain what's happening, or what things might actually be important for them to highlight. So for example, in this activity, we get them to use Google Trends to find different types of features of a time series graph. So I thought I'd share a couple of student examples. So I quite liked this one. It's really hard to use numbers, I will point out, in these, because their scale is up to 100 being the highest number of hits that they've had. So what day is it? It's an increasing trend over time with a spike. So they're starting to use that language, that terminology that we want them to be able to use when they come to sit their assessment. And another one, what time is it? I love that at the end, the student has decided that it suggests that we're getting less aware of time over time. Anyway, bit further on, the next sort of one. Asking them to find things with seasonality that isn't just yearly seasonality, and they start to get it pretty quick. So looking for things like the Olympics, but then recognizing there's little tiny ones in between and what they might be. So quickly explaining it, but without going into detail. So really concise, which is another thing that our kids need to get better at. If they're not concise, they're going to sit there and write an entire page for something that may be worth 1 mark, or they are going to run out of time at the end. All right, and just because I thought you might be interested, here's what another student put together. Just in case you're wondering, so we did this in March, the end of March, and it was right after the incident at the Oscars. So just in case you're wondering, there is a spike. All right, so yeah, EDA, we can tell from what our students have handed us back that they really do need to work on it. If we go to the next slide, this is what an EDA question looks like. Hopefully you've all seen it. And what we've noticed our kids doing is probably first and foremost, they overcomplicate everything. This is not asking for an inference, so they shouldn't be making inferences. They don't need to be making any calls with those box plots. They do need to recognize what the median is. That line in the middle of the box plot, for some reason, our kids tend to want to call it the mean. So appropriate language again, and understanding what those parameters are is really important. We are going back so many years though. It feels like it's a year 10 or year 11 type question that they should be able to answer. So understanding that not all the questions in the paper are going to be really complex, and that sometimes it is just about what they see. And also making sure that they're actually doing what the question asks. So 4 different comparisons between the various bus types. So they want you to compare, they don't just want you to make statements. So comparisons. And perhaps encouraging them at the same time that they want to be comparing between graphs and yeah, not just sticking to the one thing. All right.
That particular question is from the question 1 in 2019 paper, and it's what we did at Otago Boys for our Righty Righty this past week 4 of term 2. And after the first 12 responses in, all but one of the 12, as Amy said, called that line in the middle of the box a mean. And it's probably the first time I've been ever so slightly cross with our scholarship boys who are giving up their time after school and whatnot as well. So, but that shows the purpose and success of a Righty Righty. They will never make that mistake. They'll never make that mistake again. So we start. So I've talked about how we end our session, and Amy has as well, the Righty Righties. And I think it's important to note that we do contain it within the session. We highlight to the boys, thanks for coming, and there will be no homework in these sessions. So we do contain our Righty Righties all within that session. But we start our sessions with a tricky probability, because we know that most of the exam is interpretation, analysis, and leads to those Righty Righty skills. And it cross-links several ideas at level 8 on the curriculum. But there are a few marks available each year. I think there was 6, 8 or 10. It was somewhere in that region last year, probably closer to 6 or 8 on probability. There was a normal distribution, a tricky-ish conditional question last year. We want our boys and all our students who are doing it in the country, we want our students to still be good at that calculative side. And actually on a very low sample size, Amy laughs when I say this, better than an n equals 1, which is always 100% accurate, but based on a slightly higher value than n equals 1, looking at the last few years of scripts from our boys who bring them back at Otago Boys, there is a very strong correlation with those who get the few marks for the probability on the calculative side and get a scholarship as well. Okay, the counter of that is true. Those who aren't good at the probability tend not to get the scholarship, however good they are at the interpretation and analysis. So keeping on top of the tricky probability side is pretty important. And as I'm talking, I'm just spitballing another idea in my head. There is a little bit of a notion at our school, and I know this exists around the country wrongly, and it's easy to demonstrate how it's wrong. But there is a notion at Otago Boys that stats isn't proper maths and all of that nonsense, blah, 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 blah. And this is just a little strategy and a route in to capture our best calculus boys who are also very good statisticians. So we don't say that explicitly to the boys, but that's what we're aware of as staff and teachers doing this course. So we start each session with a tricky probability, and again, begged, borrowed, copied, stolen, occasionally our own, amended. We get them from other sources. There are some great A-level questions from the UK which overlap well. American Statistical Association has fantastic resources, ASA. There's some good questions on the mixed multiple choice SAT questions, what the kids in the States have to do to get into college in the US. There are some good questions there which overlap well, and you can spin in some good thinking. And one of my personal, we know that the web is so ubiquitous in our learning and resources these days, but one of the ones I regularly go to is braingle.com, and they have about a few hundred questions based on probability, and a number of them overlap really well, particularly with the concept side, not so much on the distributions, but particularly on the concepts and the conditionality which comes into a number of those probability questions. So hopefully, just to share, this is our folder of tricky probabilities this year, and I'm happy to share everything we've done. There's work solutions for all of them. You can see we've got the most of these are from the early sort of mid 210s, late 210s, more recent scholarship exams. So we've scraped off all the questions there and captured them as a separate tricky probability, and it takes up about 15 to 30 minutes at the start, so it's the longest starter. And again, we do feedback and go through, and we share on Google Classroom our work solutions. You'll see here, and this is one of the great joys why it's great to co-teach with a colleague. The two that I've highlighted there, it's my work solution and Paul's work solution, completely different. I'll just quickly open what that question was because I forget. It was one from 2012 about males and females doing different exercises, and the information given in ratios and fractions, and there was conditionality there. You can see how long I took to do that question because of the emoji and few at the bottom left there. But Paul's approach was completely different on that question, and it was great to be able to share that with the boys, to see two teachers approach it differently. And it was great, actually. A young man called Max shared his approach, which was completely different again. So that's an advantage which drops out of doing these tricky probabilities. The aim is to keep our boys on top of that high level calculative stuff, but it is also great to be able to share how different people approach those questions differently. We don't feedback formally, we don't mark it, we get the boys sort of to feedback to themselves. But that's how we start each session. And as I've said, analyzing our own scripts at our own school, there is a very, very strong correlation. And I mean very, very strong correlation between those who get quite a lot, most or all of the probability marks, and those who get scholarship. Both areas, the interpretation analysis complements the tricky probability and vice versa. We would never sort of focus on one more than the other. We focus more on perhaps the analysis and interpretation because there are more marks, but in terms of competency, we make sure there's equity in our course and our activities with the boys, so they keep on top of their tricky probability. I mean, I just get we just want to end and hear some questions, but in the abstract for the session today, I think I put with Anne and Robin, drill and kill, or I do know schools that do really well at scholarship. And I'll pitch a claim here that I think I've reached a level of competency and experience in sharing with colleagues like Paul at our own school and Amy and Michelle and others around the country. I could certainly say I've got the confidence and competency to get a truckload of scholarships for the boys that come and do it, but I think it would be a pretty boring course, and I don't think it would engender a love of statistical learning if we did that. But I've heard of some schools, and it's perfectly fine that really drill their kids and get them how to answer the questions, and most sessions are from past questions and past papers, and that's fine. It works for their context, and it's been great to share ideas, but we choose not to do that. The biggest phrase which I remember, which came back from student feedback a few years ago, was we enjoyed the scholarship sessions because there's food and it's fun, until term 4, where you are drilling and killing the boys for the exam. But that's the same amongst most of our senior students at some point when we get to term 4. So I spend 15 or 20 minutes before the boys arrive in the evening sessions, especially putting their tricky probabilities down, a packet of chips, a cup of juice or water, some chocolate, some lollies, and every boy comes in and that's what they see. And I know with feedback, and it's one of those guttural feelings, I'm pretty sure that makes the boys And every student, whichever learning experience they're having, deserves to feel safe and welcomed. And that's definitely our little approach at Otago Boys to make sure that happens. And certainly one of the things I've learned working a decade in boys education is that food is very, very important, regardless of the context and the learning experience. So food and fun was a phrase that came back from some feedback a few years ago. And yeah, that's how, as I say, the tricky probability is probably the second thing. The food is what the boys engage with first when they come into the room. I would say my advice, and Amy, please add to this. We're going to share some, perhaps one's mostly led from Otago Boys, and again, happy to share. But I would say we start our sessions mid-term 1. There is a little bit of a thing in Dunedin about the My Little Johnny's doing a scholarship, and so the parents love to say at the barbecues in late summer in Dunedin, My Little Johnny's doing scholarship. But we do ask that the boys get into their level 3 studies first for 5 or 6 weeks, and then make a decision. And we raise the bar, and we expect them to turn up every week, and we expect them to give the exam a go at the end of the year. But term 4 is still a while away. So whilst it is a while away, there is time, as you'll see with some of the activities that have worked at Otago Boys in recent years, there is time to take risks. And it's one of the great joys of teaching scholarship, because it is assessed on that terminal exam, and it is a fair distance away, even now in late May, that you can take risks. You can digress, you can plan something 2 weeks ahead, but something worked well in the session tonight and it deserves some follow-up next week. And it's absolutely incumbent on us to do that and carry on the joy of teaching stats. I mean, that opportunity of Will Smith that Amy's school used only came about in late March, but it's got some kids seriously engaged with their statistical thinking. What's your advice and experience there, Amy?
Yeah, I'm the same. It needs to be, the focus isn't necessarily just doing well at the scholarship exam at the end of the year. It's definitely about, these kids are learning skills that they're going to use for the rest of their life. We want them to be engaged in it. We want them to use it in their own daily lives. We want them to enjoy it, and it would be great if they took it and used it elsewhere. I mean, the reality is these kids are going to university and they are going to be exposed to stats. There's not really many, if any, courses that they're going to go off to where they don't need it. So giving them that platform and that base knowledge now, and hopefully sparking a little bit of just a little bit of excitement about it all will help them in the long term. Our kids have often said to us that it's $500 and it's not actually worth it for their time. So they aren't there for the scholarship. Some of them are there maybe a little bit more for the prestige, but a lot of them are just there because they want to learn more, and they're enjoying themselves. And food is also a big part of our program for girls and boys. Yeah, so it is about sparking that joy and making it a fun experience, as well as challenging them and setting them up well for whatever they're going to see at the end of the year. If they don't end up in the exam at the end of the year, they should still have taken away something that's going to be useful for them later on.
Just Amy's point there about university, one of the contexts in the wider Dunedin area down here is that the Otago Uni sponsor what's called town-wide subject sessions. So for the 15 or 20 biggest scholarship subjects, teachers are paid in schools to run town-wide scholarship sessions. So it might be geography scholarship is run at Otago Girls, and all the kids from the secondary schools around Dunedin, all 10 secondaries that want to do geography scholarship have an opportunity to go to a session at Otago Girls for geography. And calculus will be run at another school and another subject at another school. So that's great that kids can share that like-minded spirit and kindredness with like-minded students. But the university launched that each year with a big launch session down at the university campus. I remember at one of those years, I was talking with one of the deans of science, and he was saying they've tracked at Otago Uni, even this this anecdote is 6 or 7 years old, but I would imagine it very much could still hold true, that they track the academic performance of kids at stage 1 at university, and regardless of whether they got scholarship or not, the ones that studied for scholarship at secondary school were performing better academically in stage 100 at university. So that's a nice anecdote, hopefully to add to what Amy said there, that that they will gain something, even if they are, in statistics case, one of the 2/3 that don't get awarded a scholarship with the entry numbers and that 3% rule. They will all gain something, okay? It's tight when a student brings back a paper at a 22 out of 40, and the cut score last year was 23 that you can find out. And I think those papers tend to get marked 2 or 3 extra times because of all the extra green ink on them, from what I can gather. But they've gained, and that's one of life's resilience building experiences, failing by 1 mark in scholarship, but they have definitely gained. I'd just like to share a few activities, and just to share along lines with like Amy's EDA sessions that they do at Kashmir. One of the first sessions we did this year was based on this infographic here, and this is very much sort of aligning with the evaluating stats reports 91584. And I mean, the discussion and the exploration and the intellectual depth that boys at our school can draw out of just seeing that, when you just prompt them with, can it be claimed that the majority of Americans agree with what's highlighted in blue there, that they agree with the vaccination but disagree with the mandates that were in the States, and the discussion that follows through. And look, most of our boys are aware of who Ben Shapiro is, whether you agree with his political leanings or not. The boys are aware that he's likely to have followers on Twitter that follow his political leanings. So that's the first perhaps dodgy seed in the mix here. The boys are clever enough and aware enough and worldly aware enough to know that the mandates don't belong to Biden as it's worded in the question. So we're really drilling into the wording of the question, that it's a federal system in the United States. So each state makes up their own rules. So the question is perhaps wrongly worded to get the response that was perhaps concluded from the 53.3%. The mandates don't own, the mandates aren't owned by one single presidential figure. There's obviously a discussion about the 147,000 people who vote, whether they're representative or not, and repeated and overseas votes, etc., etc. But how clever is this, guys, that we've got 17 and 18-year-olds in this country, and this would be the same in all of your schools. They look at the date at the bottom when the tweet poll was published, and they know that's an important date in American history, and they infer, through good thinking, whether it's correct or not is perhaps another point, but they infer that September the 11th is an important date in American history. Nationalistic feeling is very highly stirred on that particular date, and this may encompass people voting repeatedly in this poll that perhaps aren't representative. So very, very cool for the kids that are not born when the original tragedy happened 20 years ago, but they can make a connection to that date. And in my mind now, one boy mentioned how at that particular time this year or last year, September the 11th, early September, late August, there was the hurried withdrawal of troops from Afghanistan from the Western coalition forces, and how that might have stirred up certain feelings which could tie into people's responses. So that the depth of thinking you can get just from a screenshot of a tweet poll is just amazing. And whether you agree with or not, that's not the point. It's the depth of thinking that can come out of there. There are obviously responsibilities on us, and I know some teachers at other schools around Dunedin that wouldn't be happy to show this particular screenshot, and that's perfectly fine. But we can all be professional enough to agree with that and share the experience that we had at Otago Boys, which was purely drawing out some good statistical thinking. We did a great activity at the start of this year. The guy that I co-teach School Stats with at Otago Boys is called Paul, and he married a lady 30 years ago who's called Paula. So we posed the question based on the boys had just done time series at this point, and we wanted the boys to think more deeply about time series. What's the likelihood of a married couple being called Paul and Paula? And the depth of thinking that the kids did from that, we wanted them to explore the ratio of males to females. We wanted them to look at births and deaths and net immigration and all of that you can see at the bottom right here. We wanted them to look at the New Zealand population. We gave them the number of Paulas and Pauls that were born in New Zealand and given that name from over the last 50 years. That's data, I think, from the Internal Affairs website. So you can see Paul and Paula both peaked roughly at the same time and are now not very common names at birth. But we got the boys to present their findings in a sort of verbal presentation, and we got the head of English to come and judge the presentations, and the best group won a wee prize, a bit of a canteen voucher. But it doesn't have to be done in a righty way. It can be done in a sort of group work competition way. Competition does work well for boys, as we know. but that was adding value to the topic at level 3 they just finished, a little bit like what Amy said happens at Kashmir, where there is some lining up of the level 3 topic and what goes on in scholarship. That was just this activity was designed to add value to their time series learning. Okay, as one boy said, it doesn't matter that there are lots of questions going on here. Are you looking at the specialness of 2 names which are basically the same and just one is for females and one for males, or any couple called whatever has the same sort of probability? So the depth of the arguments the boys presented was pretty varied, but there was one group that actually took a really good in-depth thinking and backed it up with calculations which showed it it's a very small probability. Did you know that did you know that a few years ago in China there was a study that was released for a technique to win paper, scissors, rock, and that we gave the boys, this was a year where the boys did not do experimental design at our school, but at a Chinese university, they did an analysis of hundreds and hundreds of games of people playing paper, scissors, rock. And there is a strategy that tends to win more than others if you follow this strategy. So we got the boys to play paper, scissors, rock, with half of them randomized into a group which had this strategy and half of them that didn't have this strategy. And this is the boys just having fun on the night, playing and recording paper, scissors, rock. That's a great photo of students engaged in their learning. And it is significant at the 10% level. It is significant if kids have been given the strategy. It sits in that awkward area between, on the re-randomization analysis, between 50 and 100 times out of 1,000. Following up on experimental design, one of the activities we've done this year, we did this on Thursday actually. Our boys don't do experimental design, so we just scraped off all the re-randomization questions from previous exams, and we got the boys to work in groups. And the idea of this activity was, from these previous questions, to fill in on the right hand side, to construct a really precisely, technically correct worded response. The tail proportion is 4 out of 1,000, which provides strong evidence to support a claim that cows being given this type of feed do end up producing more milk. So I'm not boasting that was particularly precise or technically correct, but the boys had 20 minutes in groups to really hone in on that precision, read what was going on with some experiments, and make sure they could nail that conclusion part about the re-randomization output for a topic that they don't do at level 3. We'd obviously been through experimental design and conduct the week before in the scholarship session. I think I've worked out, just as a quick aside, particularly on this is a good tip for those of you when you're training your scholarship kids for bootstrapping and re-randomization. What we've noticed at Otago Boys is that the question says what can be concluded from this output, both for re-randomization and bootstrapping. We know the distributions look the same, but they're completely different concepts. But that particular question, what can be concluded from this output, seems to be pretty common. I think we've worked out from looking at our papers, there's 1 or 2 marks just by responding to the basic exploratory data analysis of what results you get in the experiment itself. So there was a mark this year, I know, for this question, which said that the mean of group B was 1.69 higher than group A. But our best kids, because they're our best and most able kids, tend to go to the fancy pants technique, which is the re-randomization distribution. But as Amy said, get the kids to do that basic exploratory data analysis, even on the fancy pants high level techniques like bootstrapping and re-randomization.
And get them to circle that mean up the top too, because if they go with median, they've lost the plot. They've lost their chances.
This was an activity I did not think would work well at all, but we gave the kids, we downloaded from educationcounts.government.nz, we downloaded every single school in the country, and it was a spreadsheet with about 20 columns going across, so 20 different variables. What's a typical New Zealand secondary school? The kids have to think about a sampling method. They have to think about what is the answer to that question. Is it the average role? Is it the average demographic, etc., etc.? Our boys got to the point where they were just fascinated with the average location of a typical secondary school in New Zealand. and the average location happens to be off the Taranaki Bight, just in the middle of the Tasman Ocean, basically. So they're pretty stoked that the average school is somewhere in the ocean in New Zealand. Okay, if you do the average latitude and average longitude based on a good sampling method, that's where most of them tend to be. Okay, but I didn't think that would work well. We took a risk, and the boys really got into that.
We use the same data set, actually. We use the same one, and we get our students to do a presentation on New Zealand's most average school, and they have not yet come up with the location. But the New Zealand's most average school, of course, there's a lot of unpacking that they could do in there as well. So good fun.
And the one activity I would encourage and say, please, Mark and Amy, share this, is called a triangle test taste, where placed on a desk, and it's designed to introduce them to what simulation and variation and what chance can explain for us other than what we expect. So you place 3 food items in front of the kids with 3 very random numbers based on this listing here. And the idea is that the students with the 3 food items, in front of them, pick the one which is different to the other 2. They pick the odd one out. Now, based on a random process, if you have 3 food items in front of you, you are going to have a 1 in 3 chance of just picking the one which is different from the other 2. You've got a 1 in 3 probability of that happening. So we did this triangle test taste one year with 2 different types of orange juice. So Amy would come into a desk, and there would be 3 cups of orange juice, and there could be 2 sugar-free and 1 normal. There was Whittaker's versus Cadbury's chocolate, so she could have 2 bits of Cadbury's and 1 bit of Whittaker's. And then we said to the boys the year we did this, what's the 3rd food item? And this shows a little bit of what a decile 9 school perhaps compared to others. And I just rolled my eyeballs, but we followed through. The boys wanted 2 different types of soft cheese. So we bought 2 different types of soft cheese, and there was 2 of one type and 1 of another in front of each boy. And their job was to pick out the fruit juice that was different to the other 2, the piece of chocolate that was different to the other 2, and the soft cheese that was different to the other 2, and see if we can have a discussion. And it links in with the binomial distribution, as I say, chance and variation, and a little bit of a distant touch on formal hypothesis testing. It's a great activity. This one I captured from the States and is actually set up for elementary kids, but it can easily be progressed to scholarship stats. I think overall, there is all the activities I've looked at in the last few years we've done at Otago Boys. That's the one which was most fun. It had the most food, and it probably had the most links across most areas of the level 8 on the curriculum. It took about an hour to set up, though, just for 15 kids. That's the one caveat I would say. The last thing from me as I go 1 minute over is just to say I'm very proud to do scholarship stats and lead it with Paul and share ideas with Amy. But I am very proud that I get to teach boys that given the original scientific journal report from Professor Richard Dole, this is the original scientific paper which proved, not through experimental, but through association. And you can, association doesn't prove causation, but it can do if you do the type of study that Richard Dole did in the 50s, which was to prove the link between lung cancer and the cause of it being smoking. And so this is the original paper which kickstarted us to the state where we are now, with us trying to become smoke-free by 2025. The boys really got it. They loved the infographics and the text and the language from the 1950s. It's a 10-page report, but the follow-up righty righty and discussion you can have from this. I was so proud of boys at the age of 17, 18 who took an interest and a responsibility in reading this properly over the course of a couple of weeks and drawing out some really good statistical thinking and a little bit of history as well. The very original report that ended up being slammed by the tobacco companies, but led us to a much healthier world these days. So yeah, there's lots of very cool stuff you can do with your kids. That's me, Amy, and Anne. Anything else you want us to share, Amy?
Anything else, Amy? That's great. Thank you. I would like to share and close down the meeting, but before I do that, and I appreciate it's just a little bit over, but I'd just like to say a huge thank you to Amy and Mark. What a wonderful presentation and a wonderful way to end a fantastic another AMA Saturday morning.